Okay, so I had told you that I would be, or sent in the announcements that I would be recording a video to run you through Lab 3, and mostly because this week in the Pullman lab we had some issues with it, but they were um, mostly resulting from the Amazon workspace not having enough processing power. So in a way, they really do replicate some of the things that you might be running into, especially if your computer needs some updating, if you need to do some computer maintenance. And so some of the tips that I put in that computer maintenance for QGIS optimization definitely apply to this lab. So before you get started on this lab, please read that and enact some of those suggestions, and that will make this lab go a lot smoother. Some students have already tried to do this lab on distance, and they've made it through with the suggestions that I gave them before, which was mostly shut down the program, start it again. The same things that worked for Lab 2 would work for this lab, but what that's indicating is that your computer is not able to process the transformations that QGIS is requesting in order to make these new layers. And so if that's the problem you're having with your layers not transforming or disappearing or not lying on top of each other, things like that, that really does indicate that either your CPU is totally taxed, or your RAM, your short-term memory, is being taken up with other processes. So definitely try to limit the things that you're doing when you're trying to get your lab done. Meaning, if you have multiple tabs open in your browser, close them all out. Have Canvas open because you need it. The perusal instructions, yes. Everything else, close it down. Anything in your taskbar that's open means that it's running and using up CPU and RAM depending on what it's doing. So you want to close out any programs you're not using. If you haven't shut your computer down in a while, and you can shut it down once a day, I do mine about once a week, that will clean up your RAM and help you to get this lab done without error. QGIS does work, but it does need some available CPU, central processing unit, and some RAM. So I give you some tips in that sheet that I posted in the general resources. And if you're having difficulty completing this lab, read that sheet and do some computer maintenance, and then try again. If you're still having trouble, I'm always available. Let's start a new empty project. And I'm going to run through this now that I've spent about 5 minutes describing, how to get ready for it. I'm going to run through this very quickly. The point of this lab is to learn about projecting geographic data. And I've talked a lot about the, I'm actually recording. Which window am I recording? I'm recording this window. And I've talked a lot about the coordinate reference system and why it's important to have things in the correct coordinate reference system. In Lab 2, we practiced measuring the distance across the United States. First, we measured it in the Mercator, and we recorded the miles, and it should have been around 3,100 from LA to New York. And then we recorded it. We switched the project CRS and loaded the Albers layer to the CONUS equal area, and we recorded the value there, and it was 2,400. So we talked about projections distorting the area and the distances, and we're going to look at that again today. So you're going to be bringing in a layer, and instead of just changing the project CRS, which is the display, we are going to be changing the layer CRS by making a copy of the layer and then setting it to a new coordinate reference system. Okay? And we're going to do this 3 times. So we'll have 4 maps in all, and we'll put those 4 maps on a single sheet, a single print layout. Okay? The second map is much easier. We do a map where we bring in some Whitman County roads of Washington, and they do not have a projection defined, so they don't line up with the Whitman County layer, and you define the projection based on what you know about it. We end up telling you the projection, but there are ways of finding out what a projection could be, and I'll talk about them as I go through the lab. So the first thing you're going to do is you're going to be bringing in a layer, and it's the only layer in your Lab3 geo package. It's the Washington 4269 polygon layer. And if you notice, before you bring any layers in, your coordinate reference system, that's the default for QGIS, is 4326. So we are going to bring in the 4269, and as soon as you bring in that first layer, the project CRS will change to that first layer. Okay, so it will display correctly in the 4269 projection. And both of these, the 4326 and 4269, are just geographic coordinate systems, meaning they're latitude, longitude for units, and they're based on the spherical model of the Earth. So they have no correction for the distortion that you get when you take a spherical model and you flatten it, which is why they are distorted east to west. Okay, so we are going to use a tool, and it's commonly found in the processing toolbox, which is a tool that looks like a gear, and you should have that in your QGIS already loaded. I'll show you another place to find this tool also. So here we are with a new project. I'm going to use my browser tab. I am going to go to my folder where I have unzipped, and it should be in a folder called Soils 368. And the geo package has one layer called Washington. Yours might be Washington 4269. It might not have counties. And I'm going to drag it in. And there it is. Mine has the Puget Sound kind of nicely detailed. Yours might not have that detail in it. You can see that we have one layer in here, and it's stretched out east-west. This is not the shape of Washington. And now the CRS of the project is 4269, which matches the CRS of the first layer. What we are going to do is make copies of this layer, and when we make copies or duplicate it, we can set the CRS to whatever CRS we want. Okay? There are two particular coordinate reference systems that have both a NAT83 geographic coordinate system and an additional projected coordinate system that we are going to use that are specific for Washington. One is the Washington State Plane coordinate system, and the other is the UTM Zone 11. Both of those are really good at preserving area and distance for the state of Washington. The third projection that we're going to use is WGS 84 World Mercator, and it does have a GCS, which is WGS 84, and a PCS, which is the World Mercator. But that World Mercator is really designed for a more global transformation, and so it does not preserve area for Washington State. So what we're going to get is a fourth projection that looks very much larger than the other two that are meant for Washington State. Okay, so how do you do this? In the directions, it says to go to your processing toolbox. And so if you don't have this, very few cases, it might be not installed. You'll go to plugins, manage and install plugins, and you'll search for your processing toolbox. Okay. It is not wanting to search. Let's see if we can get down to P. There it is. Okay. See how it's checked on because mine's installed? You might need to check it and check it on, and then check it off, and install it. And then you'll have a little gear in your toolbar. So you can either click on this is the directions, and you type in reproject, and this tool comes up, reproject layer. It's a vector tool. when you reproject a raster, you do something called a warp. So that's different. You don't want to do that. So you can either do that through here, or you can come up to your vector menu toolbar under data management, reproject. It'll open up the same window. I want the input layer as my Washington Counties 4269, and I want to reproject first to the NAT 83, so the same geographic coordinate system but with an additional projected coordinate system called Washington South. And we are going to save this layer, so click on the ellipsis, save to GeoPackage, navigate to your Lab3 GeoPackage, and save, and then name it Washington 2286. After you've done that, run. If it works correctly, you will get a second layer. So you'll have another, it'll be the same shape but a different color, and you'll have two layers over here. Uncheck it. Yep, the purple is underneath. Notice how your project view is still in your coordinate reference system of the first layer, which is 4269. So if you want to see this in the 2286, we're going to rename this 2286. You have to right click, layer CRS, set project CRS from layer. And it didn't work, which tells me that this is not working. So, because this is a live demo, it's very, very authentic. Discard the project. As much as I hate to have to start over again, this is probably what you're going to have to do unless your computer is very powerful and you have nothing else open. Open up a new empty project. And the Washington counties. And reproject again. Sometimes you can, before you start reprojecting, change the project CRS to your future projection, and that will let you know if your software is going to be performing for you. So I changed this to 2286 already. Now I can change it back to 4269, and then I will reproject. Save it. So now, let's see if the pink is underneath. It is. There's two layers there. Let's see if it is reprojected. Set product CRS from layer. Yes, it changes to that 2286. So now it truly is in 2286. Now that we've made sure of that, we are going to update the attribute table. This attribute table has two fields called shape length and shape area, and they are very small numbers because they are in the units of this layer, which is degrees. How do I know this layer is in degrees? I right click, I go to properties, information, down here under units, geographic uses latitude and longitude. Here, this layer is in feet. Okay, so let's take a look at the attribute table for this layer. The numbers are still the same as the Washington Counties 4269. The attribute table area and length and perimeter needs to be updated. So the way you update it is you turn on editing, go to your field calculator, update existing field, update the length first, which is the perimeter of each of those polygons, and it is I give you this in the directions, perimeter, parentheses, $, geometry, it says basically what this is saying is recalculate the perimeter based on the geometry of this layer, which is in feet. Okay, now those numbers seem a lot more in line with the perimeter of a county in feet. Then you can update the area. So I always do the perimeter first, then the area. And then you will add a new field because this area is a very unwieldy number when it's in feet squared. So we're going to convert to square miles. Let's call this square miles. Do it in decimal numbers so it'll be really accurate. And the way you get the square miles is you're going to multiply the shape area, which is in feet squared, double click and it puts it right in there, times. So the shape area is a number in square feet, right? So say 15 million square feet times the conversion factor of whatever square feet to square miles is. So I'm going to open this up. Square feet to miles. And usually it just goes right to a nice site. There we go. And you're going to copy this number. Close this out. And paste it right in here, just like that. And then you can sort this this field for county names just by hitting that field name. And Adams County is the first one, and do a double check to make sure you did the calculation right. For the Washington State Plain, area of Whitman County should be 1,929. So where do you put that number? Come to your data sheet that you have that's in the package. And these first A, B, and C are the areas of Whitman County for each of the following projections from the attribute table. So that's where you'd put that, the area of Washington or Whitman County, which is 2,177.34 square miles. You'd put that in this data sheet right here. You have to reproject 4269 into 26911 and update the attribute table. This is in meters though, so it's a different conversion factor. And then do that process one more time for the World Mercator to get the area for World Mercator. Just as a tip, World Mercator distorts the area of Washington State to almost double. So the area of Whitman County will be almost double the area in Washington State Plain and UTM zone. So you didn't do it wrong if it's almost double this number. Okay, the second part of this data sheet is finding the coordinates of the northwest corner of Mason County for these 4 different CRS, coordinate reference systems, NAT 83, UTM zone 11, Washington State Plain, and World Mercator. You can do this all in one map. You don't need to change the projection. I'll show you how to do that. You'll come back to your map. I like to do this just for the very first projection. Unless you know where Mason County is, you don't really want to guess. I mean, you could do the identify tool and it would tell you this is Okanogan County, this is Chelan, this is Whitman. So you could like hop around the 39 counties or whatever there are in Washington. I don't know how many counties there are. Let me take a look and see actually. Yeah, there are 39 counties. Or you could select, go to your attribute table, and this very first column, if you select this number on the left-hand side, it will highlight the row of that feature, and then it also highlights it on the map. See how there's red X's all over it? That means my attribute table is being edited. So I will save my edits and stop. Okay, and then it's still selected, but now it doesn't have all those red X's on it. So let's zoom in on this northwest corner. and then you're going to right click, copy coordinates. And here we have the coordinates in the 4269, which is the NAT83. You can right click, go right to your data sheet, and that's NAT83, so it's these. Right click and paste. This is the X, which is longitude. This is the Y, latitude. Okay? These numbers are going to be different for every one of these coordinate systems because they don't all have the same 0, 0 or the same units. So that spot on the map will have different numbers for each one of these coordinates. So for example, for the 2286 or Washington State plane, that same spot is 899,844 for the X and 843,504 for the Y. So very different from the longitude and latitude. If you work enough in these coordinate reference systems, you start to recognize these numbers, and then you can immediately identify what coordinate reference system you're in and kind of roughly where you are. Some of us are familiar with the latitude and longitude, so we kind of know that Pullman is, you know, a certain longitude, a certain latitude. I like to ski at what is it? I can't remember. 49 degrees north, and so that they named it after the latitude that it was located on. So we're familiar with things being expressed and finding them on the globe in latitude and longitude, but not so much with Washington State plane or any of the other these coordinate reference systems. But so this is the number for 2286. I come back to my data sheet. That's right here. I paste. I take it and I bring it over, and that's my X and my Y. I do the same thing for UTM Zone 11 and World Mercator, but how do I find those? Because they're not on here maybe. I go to Custom CRS. I find the 26911. I say OK. I right click, and there it is. Right click. And let's take a look at these numbers. Remember that that X is going to be between plus 500,000 and minus 500,000 because the middle point is 500,000. And this Y is from the equator. So that's why it's in the millions. That's the 0 point for the UTM zone. Okay, so then you go back and you do the same thing to get that World Mercator. All right, so that's essentially that first exercise is reprojecting 4269 into 2286. And then you're going to go up and reproject it again. Normally you could do this in the same layer all 3 times. It was causing problems, especially if your computer is already not handling the transformations. So I had students do this in only 1 projection per project and shut it down. So if you're able to do it all in one, great. If you're not, then shut it down between projections and just reproject completely just 1 time in each project, and don't save the project. It looks like here, I just removed that layer that I reprojected, but it looks like here it worked. Okay, so then you're going to reproject and get that 26911, update the attribute table, get the area for Whitman County. Okay, the last thing you're going to do is make a new print layout, and you will drag I showed you guys a shortcut because the long cut wasn't working. So you'll drag in 1, copy, paste, copy, paste, copy, paste, or just V, Control C, Control V 3 times. And yes, it's all the same color. This is all from that 2286 layer. But what we can do as a shortcut here is we can change the CRS right in the print layout. Okay, and then you would set this to 8 million. I want the scale to be 8 million for all of them. So set the CRS first, and then the scale. Yes, it should be very small. We'll keep this one at 2286. I think I have it in a different order on the print layout. The 3395 is going to be very big because it's a World Mercator. So it's bigger than the other ones. And this one is 26911. I always set the scale after. So these are similar in size. This one's much smaller at 1 to 8 million, and the enrollment indicator is very large. That's why the size is so large for Whitman County when you record the size. So that's the print layout. I have some more details about what I want you to add. So all I want to say about this lab, the map 2 is much faster. But if you have trouble with your transformations, remember to shut things down, run just QGIS, and see if that helps. Shut your computer down. If it really isn't working, start it up again, clear that RAM. Okay? And let me know how you're doing. I'm going to be around this weekend. Of course, I have office hours on Monday from 10 to noon and 6:30 to 7:30 in the evening. Take care.